A multi-source observability platform ingesting synthetic checks, SNMP, flow records, OTEL spans, and Kubernetes metrics at enterprise scale can generate well over 1 million data points per second. Keeping all of it at full resolution indefinitely is technically possible and financially irrational. Storage economics require deliberate choices: what resolution to keep, for how long, and for which source types. Recording rules and per-metric retention are the tools that make those choices systematic. Retention tiering is the practical answer to storage economics. Keep raw data for 7 days, full resolution for incident response on recent events. Roll up to 5-minute averages for 90 days. Recent trend analysis and weekly reporting still work well at this resolution. Aggregate to hourly summaries for 1 to 2 years, sufficient for capacity planning and annual SLA reporting. The storage cost difference between raw and hourly is typically 50 to 1. The same data tells a different story at each tier, and you only need the raw resolution when something just happened. Recording rules pre-compute common aggregations at data write time, storing the result as a new metric. Instead of aggregating 500 per pod CPU series every time you open a dashboard, a recording rule computes the namespace level average once per interval and stores it. Every subsequent query reads one series instead of 500. At scale, thousands of pods, hundreds of dashboards, dozens of engineers, recording rules convert expensive repeated computations into cheap lookups. They're also the primary tool for cardinality reduction without data loss. Drop policies and rollup policies serve different purposes. A drop policy deletes data past its retention window, simple, irreversible, appropriate for high cardinality raw data, where the cost of retention exceeds the value. A rollup policy compresses old data into aggregates before dropping the raw record, more complex, but preserves the trend without the resolution. For most source types, the right answer is rollup for long horizon data, drop for high cardinality short-lived data like raw trace spans. One of the most important retention decisions is that different source types warrant different policies. Synthetic check results are small and highly actionable. Keeping them raw for 30 days is inexpensive and useful. Raw flow records are enormous and aggregate well. 7 days of raw plus 90 days of rollups is a common pattern. High cardinality OTel traces are expensive. A 24-hour raw window with sampled retention is typical. Per-metric retention lets each source type be tuned independently. The evaluation question: does the platform support per source type or per metric retention policies? If retention is a single global slider, you're either keeping high-cost raw flow data longer than you need it, or discarding low-cost synthetic data sooner than you should. Per-metric retention is the difference between a storage cost that scales with data volume and one that scales with data value.